Hello students, this is Sir Murtaza from Al Murtaza School and welcome you to another lecture of physics. So let's begin. So first of all, again what we are going to do, we will look onto the agenda of this lecture video. So in this lecture video, we are going to discuss or we are going to learn about numerical questions. Okay, so we are going to solve numerical questions in this lecture video. So let's move further. So first of all, you have a question, which is question number 1. Okay. So in this question, you have been asked that express the following quantities using prefixes. Okay. So what they are going to do, they will be giving you some quantities and you have to use prefixes. Okay. So here I have some questions. The first part is 5,000 grams. We have to use prefixes for this expression. Okay. And the second is 52 exponent minus 10 kg. So here I have two questions. Okay, we will solve it one by one. So first of all, we are going to solve the solution for part 1. In this question, first of all, what we have to do, we have to just write the question. The question is 5,000 grams. Okay, then what we have to do, we have to use prefixes. Okay, and we know prefixes are used with the help of exponents. It could be exponent 3, it could be exponent 6, it could be exponent minus 6, and so on. So we have to convert this expression by using exponent. Exponent means 10 raised to the power. Okay, so what I can do, I can write 5,000 grams as 5 multiplied by 1,000. Okay, we can write it. When we multiply it, we will get the same thing, which is 5,000. Okay, then what I can do, what I can do is I can write 1,000 grams as 1 kg. Okay, we know that 1,000 grams is equal to 1 kg. Then the answer is 5 kilograms. Okay, so we can write 5,000 grams as 5 kg. And here I have used the prefix kilo. Okay, very simple. Just what we have to do, we have to, whatever number we have given, we have to convert it. First we have to use exponents, then we have to use the relatable prefix. Okay, let's move on to the second question. In the second question, we have 52 exponent minus 10 kg. Okay, first of all, what I have to do, I have to write it in the standard form. Okay, so what is the standard form? In the standard form, we need only one digit before the decimal. Okay, so here you can see that the number is 52. So the decimal point is here. Okay, now what I have to do, I have to shift this decimal towards left so that I could get one digit before the decimal. Okay, so we can write it as 5.2. So if I shift my decimal one times or one digit towards left, so what will happen, I have to add plus 1. Okay, this is the solution. So while adding plus 1, what it happens, minus 10 plus 1 becomes minus 9. So 52 exponent minus 10 can be written as 5.2 exponent minus 9 just by shifting the decimal one times towards the left. Okay, then what I have done, I have removed this kilo. Okay, and by removing this kilo, I can use the prefix exponent 3. Okay, then we have to do a little maths. In maths, you know that whenever the bases are same, so what we have to do, we can add the powers. So here exponent minus 9 and exponent 3, both the bases are same. So by adding the powers, what will happen, minus 9 plus 3 will become minus 6. Okay, and in the last step, exponent minus 6, the prefix for exponent minus 6 is micro. So this is our answer. So what I have done, I have written 52 exponent minus 10 kg as 5.2 micrograms. Okay, so in this way, what we have done, we have used prefixes for the given quantities. Okay, understood? Now let's move further. So now in question number 2. Question number 2 asks that rewrite the following in the standard form. Okay, so what we have to do, we will be given again some quantities and we have to write it in the standard form. So here we have some questions. The first question is 1168 exponent minus 27 and the second is 0.02 exponent minus 8. Okay, so first we will start with the solution for part 1. So first I will write the question, which is 1168 exponent minus 27, and you have to keep in mind the standard form. For the standard form, we just need one digit before the decimal. Okay, so here you can again see that the decimal point is here. Okay, so what I have to do, I have to shift the decimal 1 2 3 times towards left. Okay, and you know that whenever we shift the decimal towards left, so the power will be in positive. And what will be the power? The power will be how much digit you have shifted that decimal. So I have shifted the decimal 3 times, so it means it can be written as 1168 can be written as 1.168, and the power I will be using would be exponent 3, and exponent minus 27 will be copied as it is. Okay, then again what I have to do, I have to multiply these two numbers, which is exponent 3 and exponent minus 27, and the rules are both the numbers have the same basis, so we have to add its power. Okay, so 3 and minus 27 will become minus 24. So this is the correct answer. Okay, correct answer means that this is being written in the standard form. So we can write 1168 exponent minus 27 as 1.168 exponent minus 24, and this is the standard form. And in this standard form, only one digit is written before the decimal. Okay, got it? Now let's move on to the part 2 of this question. In the second part, the question is 0.02 exponent minus 8. Okay, so now here, what I have to do is, in order to make it in the standard form, the decimal is here. Okay, so what I have to do, I have to shift the decimal 1, 2, 2 times towards the right. Okay, so whenever we shift the decimal towards the right, so the power will come in negative. Okay, and what will be the power? How many digits you have shifted the decimal? So the power would be exponent minus 2, and this 0.02 will become 2. Okay, and this is exponent minus 2, this is exponent minus 8. Again, simple, you have to just multiply these two numbers, and to multiply these two numbers you have to add their powers. Okay, because whenever the bases are same, you have to add the powers. So minus 2 minus 8 will be minus 10. So the correct answer is 2 exponent minus 10. Okay, so this is the standard form for the expression 0.02 exponent minus 8. Okay, now let's move on to the next question. Now, in the next question, they are asking, what are the significant figures in the following measurements? Okay, so here you have been given some measurements: 1.009 meter, 0.00450 kg, 1.66 exponent minus 27, and 2001 seconds. We just have to tell that what are the significant figures, or you could say that how many significant figures are there in these numbers. Okay, so for this you have to remember the rules for the significant figures. Okay, so the answer for part 1 is 4, because we have 4 significant figures. Why there are 4 significant figures? Because 1 and 009, all these are significant figures, because non-zero digits are considered as significant figures. And when we talk about zeros, so zeros after the decimal are considered as significant. So here all the numbers are significant. Okay, now let's move on to the next question. Next answer. The next answer is 3. Why it is 3? Because now we are talking about this number. This is 0.00450. Okay, so here how many significant numbers we have? Just 450. These zeros are not considered as significant numbers, because zeros before non-zeros, okay, zeros before non-zeros are not considered as significant figures. So 1, 2, 3, these 3 zeros are not considered as significant figures, but 4, 5 zeros are significant. Okay, this 0 is also significant because it is after the decimal. Okay, part 3 is very simple, because all of them are non-zero numbers. So we have 3 non-zero numbers, so again the answer would be 3. Okay, very simple. Now for part 4, you can see the number is 2001. Okay, 2 and 1 are non-zero numbers, so they are significant. And if we talk about these 2 zeros, so again these 2 zeros lies between 2 non-significant number, two non-zero numbers, non-zero numbers. These two zeros lies between 2 non-zero numbers. That is where they are significant. So the answer would be 4. Okay, so in this way, we will tell that what are the significant figures, or how many significant figures are there in this measurement. So this is the answer for this question. Let's move on to the next question now. Okay, now in the next question, they are asking, a chocolate wrapper is 6.7 centimeter long and 5.4 centimeter wide. calculate its area up to reasonable number of significant figures. Okay, this will be the last question for this lecture video. And in this question, there is a numerical question. Okay, numerical question means that they have given some data. What they have given, they are talking about a chocolate wrapper which is 6.7 centimeter long and 5.4 centimeter wide. So you can say that they have given its length and its breadth. Okay, what we have to do, we have to calculate its area. Okay, so for this you have to remember the formula for the area. The formula for area is length into breadth. Okay, because here we are talking about a rectangular shape. Okay, so for a rectangular shape or for rectangles, the area is length into breadth. So we will find the area for this chocolate wrapper with the help of formula length into breadth. But they have put one condition for this question, which is up to reasonable number of significant figures. Okay, so what does this mean? This is very simple. Just we have to do whatever the answer will come, we have to round off it till two significant digits. Why two significant digits? Because 6.7 centimeter and 5.4 centimeter both consist of two significant digits. It means that data consists of two significant digits, okay, or two significant figures. So the answer should also be in two significant figures. Okay, so the procedure for solving a numerical is, first we have to write the data. Okay, so in the data, what I have done, first of all, I tell that the length of chocolate wrapper, which is represented by L, is 6.7 centimeter. Then width of chocolate wrapper, which I have represented by W, you can also represent it by B. There is no issue because width and breadth both are same things. Okay, so W, which is the width of the chocolate wrapper, is 5.4 centimeter. And what we have to do, we have to find the area. Okay, this is our data. Now in the solution, what I have done, I have used the formula area is equal to length into breadth. Okay, again I have told you that breadth and width both are same things. Okay, just we have to put the values. Length is 6.7, breadth is 5.4. When we multiply it with the help of calculator, so the answer will be 36.18 and the unit will be centimeter square. Okay, so as they have told that we have to find the area up to reasonable number of significant figures, so we have to round off it to two significant figures. Why two significant figures? Because I told you before, because the data has been given in two significant figures. So very simple. When while rounding off, again you have to remember its formula, its rules. So what is it? We start from the last digit. 8 is greater than 5, so just we will omit this and add 1 to it, and then this will become 2, and 2 is less than 5, so just we will omit this number, so the answer will be 36 centimeters square. Okay, so in this way we will find the area for this chocolate wrapper up to reasonable number of significant figures. So this is it for this video. Hope you understand all the questions properly, and meet you inshallah very soon in the next video. So till then, very goodbye.